simplify the complex fraction. We have here a complex fraction. That is a fraction whose numerator or denominator has more than just a polynomial as a rational expression itself within the numerator or the denominator. So here we have some rational expressions sitting in the numerator, another rational expression sitting in the denominator. So we got a lot of fractions going on, and that's confusing. All right, I have some grasp as to what a fraction looks like, but all of a sudden make the numerator something that has a fraction in it, and make the denominator something that has a fraction in it, and this is confusing, right? We have a hard time, at least I have a hard time, thinking about a fraction 1/2 divided by 7/9. I look at that and I say, gosh, I'm not even sure if that's, close to 1 or close to 0 or close to 4 or what. I have to think about it, figure out what's going on. Of course, one of our options is to rewrite this division. Right, that's division. So to divide 7/9 into a half, we'll take 1/2 times 9/7. So that's one option to rewrite a complex fraction. Invert and multiply. We could do that here. That's not the option that I would like to pursue. There's a generally nicer, easier to work with option, and that is to go ahead and to try and get these three denominators to cancel, right? And I know how to get a denominator to cancel. If I have a fraction, say 1 over a, and I'd like the a to cancel, well, if I multiply by a, then those a's cancel. And we're in luck because I can multiply by whatever I want. If I wanted to multiply, say, this denominator by a, I could do that as long as I also multiply the numerator by a, and then I'm multiplying by this fancy version of the number 1, right? So we're going to pick some fancy versions of the number 1 to multiply by so that these denominators cancel. So what do we need to multiply by to cancel this x squared minus 1? Well, x squared minus 1. Doing this multiplication, this product, the x squared minus 1s are going to cancel. Okay. What do I need to multiply to get an x minus 1 to cancel? Well, I'm going to have to multiply by an x minus 1. What do I have to multiply by to get x plus 1 to cancel? I'm going to have to multiply by an x plus 1. All right. Of course, to do each of these 3 multiplications I want, I'm going to have to do the same thing in the numerator as I did here, and the same thing in the denominator there, right? But here where we're in luck. We don't actually have to do anything extra because x minus 1 times x plus 1 is equal to x squared minus 1. So I actually do have already, with what I've written, the same thing in the numerator and the same thing in the denominator. So this is already a fancy way of writing the number 1. Let me just clean this up. X minus 1 and x plus 1. So I have an x squared minus 1 in the denominator. I have an x squared minus 1 in the numerator. It's written a slightly different way, but they're equal. That means all this is, oops, changed color, but that's okay, is a fancy version of the number 1. Right? So what do? Now I can cancel. X squared minus 1 times this x squared minus 1, those two are going to cancel, leaving me with a denominator of just 1. So that's great. What happens in the numerator? Well, here I got to distribute, right? I'm multiplying x minus 1 and x plus 1 times 2 over x minus 1, and x minus 1 times x plus 1 times x minus 1 over x plus 1. So when I multiply by this piece, my x minus 1 is going to cancel with that x minus 1, and I'm going to have left a 2 times x plus 1. So I'll write that down. Right. Plus, when I do this product, what cancels? The x plus 1 is going to cancel with that x plus 1, leaving me with an x minus 1 times an x minus 1. So I'll have an x minus 1 squared, right? X minus 1 times x minus 1. So that's what we have. Let's not bother writing this 1 in the denominator anymore. Let's do a little bit of multiplication, square this out, factor in the 2, combine some like terms. 2 times x plus 2 times 1 plus x minus 1 quantity squared is x squared minus 2 times x plus 1 squared. So we get that. Combine some like terms. I have 1x squared. 2x minus 2x, those cancel. 2 plus 1 is plus 3. So it looks like our simplified form of this complex fraction is none other than x squared plus 3.